Welcome back to Lumicore Labs. Day 16. It's practice day for error handling. Last time you learned how to use try and except to catch errors before they crash your program. Today we're going to practice that skill with 3 short challenges. Each one simulates a real-world situation where things might go wrong. Pause after each challenge, try it yourself, then watch my solution. Let's make your code unbreakable. Challenge 1. Safe number input. Ask the user for a number. Use try and except to handle the case where they type something that's not a number, like hello. If conversion fails, print a friendly error message. If it succeeds, print the number doubled. Pause now and try it. First, I'm printing a header so the user knows what this program does. I store whatever the user types in a variable called user_input. At this point, it's just text, even if they typed a number. Now I start a try block. Everything indented under this line is code that might fail. I'm telling Python, be ready, something could go wrong here. Inside the try block, I attempt to convert the input to a float. If the user typed a valid number, this works. If they type text, Python will raise a value error. If the conversion succeeded, I print the result. The number is multiplied by 2 and displayed using an F string. I print a friendly error message. No scary red text, just a clear message telling the user what went wrong. I'll enter 5.5. The try block converts it to a float, no problem. 5.5 times 2 is 11.0. Now I'll enter hello. The float conversion fails with a value error. The except block catches it and prints not a valid number. No crash, no red error, just a friendly message. Challenge 2. Safe division. Ask the user for 2 numbers and try to divide the first by the second. But this time, handle 2 different errors. A value error if they type text instead of numbers, and a 0 division error if they try to divide by 0. 2 except blocks, 2 different error types. Pause and build it. You need 1 try block and 2 except blocks. Python checks them in order, top to bottom. The first matching one runs. Make sure you catch the right error for the right problem. I get both numbers as strings. I'm not converting them yet. That happens inside the try block, where it's safe. The try block starts. All the risky operations, conversion and division, go inside. I convert both inputs to floats. If either one fails, for example, the user typed ABC instead of a number, Python jumps immediately to the except block. Now I divide. If n2 is 0, Python raises a 0 division error. If both numbers are valid and non-zero, the division works perfectly. I print the result. This line only runs if both conversion and division were successful. First except block catches the case where the user entered text instead of numbers. Second except block catches the case where the second number is 0. 2 different errors, 2 different friendly messages. This is a step up from challenge 1. One try, 2 different things that can go wrong. Let me show you the solution. I'll enter 10 and ABC. The conversion of ABC to float fails. Value error fires. Now 10 and 0. Both convert fine, but 10/0 crashes with 0 division error. The second except block catches it. Now 10 and 4. Both convert, division works. Result, 2.5. All 3 scenarios handled gracefully. Challenge 3. An unbreakable input loop. Use a while true loop to keep asking the user for a number. Inside, use try/except to catch bad input. If the input is valid, print a success message and use break to exit the loop. If invalid, print try again and let the loop continue. Pause and build it. While true means this loop runs forever, until something inside forces it to stop. That something will be a break statement when we get valid input. Inside the loop, I ask the user for a number. This question repeats every time the loop runs. The try block starts. This is where we attempt the risky conversion. If it fails, the accept block catches it and the loop continues. I try to convert the input to a float. If successful, the code continues to the next line. I print a success message with the valid number. Break exits the loop immediately. The program only reaches this line if the conversion was successful. This is the only way out. If float fails, Python jumps here. I print try again, and the loop goes back to the top, asking for input once more. This is the pattern that real programs use. Keep asking until you get something valid. No matter how many times the user messes up, the program stays alive. Watch this. I'll type hello, try again, ABC, try again, 123, valid. The loop breaks and the program ends. You can't crash this with bad input. It just keeps asking politely. Great work today. 3 challenges, 3 different error handling patterns. You can now write code that stays alive no matter what users throw at it. In the next video, we're entering a whole new chapter. Functions, reusable blocks of code that will change the way you structure your programs. Hit the like button and subscribe to Lumicore Labs, and tell me, which error do you see most often in your own code? See you on day 17.